Hi everyone, my name is Michael Solati, and I'm going to be discussing with you guys how to structure and build your Angular applications with scale in mind. And what I mean by that is you guys probably do a lot of things for your development environment that might make things faster or easier to work with, whether that's using something like Redux for your state management during development, or using hot module reloading for your modules and your components when you're developing, but there's other things that you can do when it comes to your the application that you ship to the users, which is really important to consider. And hopefully we'll be able to go over some of those things today. So, hello. Like I mentioned, my name is Michael. I have been an Angular developer since the early RCs, I think maybe one of the last betas for Angular 2. So I've had the opportunity of learning and suffering through the changes of Angular. And I'm hoping for some developers who are new to Angular or who have some experience with Angular, I'll have the opportunity to impart some knowledge and alleviate some of the pain that you might have to suffer, just because I've already done it. And I'm going to tell you some of these things that you can avoid. So we have three major keys to success. The first one we want to consider is lightening the load. What we just mean by here is a concept called lazy loading. We will obviously get into it. Our next one is we're going to cancel all of our subscriptions. If you're familiar with RxJS, you know what observables are. And if you've been developing Angular, you've been using RxJS or observables. So these are things that we want to be able to clean up. And the last thing is caching all the things, which hopefully you'll see what I mean when we get to that. So when we discuss lightening the load, like I mentioned, we want to do something called lazy loading. And if you're not familiar with the pure concept of lazy loading outside of Angular, what lazy loading essentially says is that assets that we want to use will come in when we need them. So instead of loading everything or making all the requests up front at the same time, we'll only do that when we need these assets. So if you were to generate a component in your Angular application, you would do a simple command like this, ng generate component, with the name of the component that you want. And after that, you would get greeted with some log like this saying that your component has been generated. You'll get a list of some files that have been generated for the component, and finally that the app module has been updated as well. And so you can see here we have our app module with our hello component that's been added to it. But what happens when we're working on an application that's a little bit larger than just a hello component? What if we're dealing with an application with only 4 routes, 4 simple pages? And even those pages are pretty simple. All of a sudden, we have a module thing that becomes massive. I think we go from roughly 20 lines on our first app module to 60-something lines in our second app module. So we want to be able to kind of lighten that load. As I said, it's a repeat term, lighten the load, lighten the load. Hopefully you'll appreciate that. Before we get there, though, I just want you to take a look at this bundle. We saw what we had before. I'll just go back for a second. OK. We see here I have all of these imports, whether that's my browser module, ng module, material module, and then I have a few components that I've created, and a few services and route guards that I have here that I'm implementing. When we get to generating our actual application, our bundle will look something like this. And specifically, you can see that the code that we write, those components, those services, those guards, takes roughly 31 kilobytes. This isn't a lot. 31 should load in fairly fast. But I've described a really simple application. I've described roughly 4 components total with the 4 routes associated to those components. And if I actually showed you the code for those components, they probably max out at like 10 or 12 lines of HTML each. And the services themselves are fairly simple. So what happens when you have an application that's maybe 100 components and directives and services? What if your components end up becoming more complex when it comes to their view? All of a sudden, that roughly 30 kilobyte size can load up. You might be loading up an application that's a megabyte in size, potentially. So what we do with lazy loading, instead of bundling everything up into that main module, you can see we have a slightly larger bundled files. And I'm just going to go back. You can see here I have a total of 6 chunks that we load in, compared to now when I'm applying lazy loading, I have 10 modules total loading in. Our main module, what we load in, that app module, is now down to 13 kilobytes. So we roughly cut a third of that initial payload of our application. And all of our routes and components are now being imported separately, and each one of those is roughly 10 or less kilobytes. Again, for a small application, not that big of a deal, but think about if you're building an application for, I don't know, something that's, like I said, it's going to mention the higher 100 or so components, or all the different services and whatnot. So what you end up having when you do the lazy loading is something like this. Now you can see in the, trying to get stage possession. You can see on my, you can see in the console that when we load in the thing, we see the 0.0 chunk, and when I click the sign in, on the very bottom, you see a new chunk gets loaded in. As we go from our main page to the second page, we fairly quickly loaded in our second module. And you can see it was almost instantaneous. There was no change, but we are going to the server requesting a resource, and we're bringing it back and loading it into the view. Now, that seems fairly easy, and that's too good to be true, and it kind of is. There's a little bit more work you need to do in order to be able to implement lazy loading. The first thing that we need to consider is routing. Before my 4 routes, I defined them something like this. I listed my 4 routes, I declared the components for them, and I activated my guards for them as needed. But if we want to do something like lazy loading, this isn't quite the best way or the way to do it at all. First thing we're going to do is we're going to take every route and the set of components that really belong to that route, and we're going to create a module for them. And we see here we have our module where I have common, shared is created, we'll get to that later. Our home routing module. So for this module, which is going to include, in this case, 1 route, but maybe you might hold a few routes. So we're going to define a routing strategy for that, which is really similar to the routing that I showed before, and we import the components in our declarations. Once we have a module declared for this route and these components for the route, we go into our app module and we will strip all reference from the components that we had created now. Because we're lazy loading these routes and the components associated with them, we don't need to bring them into our app module for that entry point. Which brings us kind of to the question, well, if I'm not importing into our app module, when do we actually get these resources that we need? When do we get these components and routes? Well, we're going to go back to our routing module that we saw before, and we're going to change it. Before we listed component, and then the component we wanted to render. Now we're doing load children, and you can see I have the path in my source folder to the module, and at the very end you see the hash bang and the module that we're importing, because theoretically you could declare a few different modules to export out of that file. So we have to be explicit with which module we want to load in there. The other thing we need to consider is the actual modules. Now, before I mentioned and I showed that we might be using something like the Angular material library. And if I just did the work I did there and I left it at just that, I would start having thrown hundreds and hundreds of different errors. And specifically, it would be saying something like, let's say if I wanted to use the Angular material cards, it would say mat-cards not found. Are you sure this is an Angular component? Please declare it. If you looked at some of our previous slides, and we'll get to that, you'll see that we're not referencing that anywhere. I was referencing the shared module in my home module. And what I'm going to be doing with our shared module is I'm going to take any of these modules or libraries that I'm using that have to be used across our modules, across our components, across our routing, and I'm going to import all of them into our shared module, and I'm going to export them out of our shared module. That way, wherever I need to be able to use flex layouts, material module, or the reactive forms module for my Angular forms, I just import the shared module into that module. So like I mentioned before, in the home module, I was importing shared module. Shared module was something I created where I'm importing all the assets that I will be using across the website or across my web app, and I export them from there. That way, I only need one module to get every asset and resource I need. And you can see in here in my main app module, I also import my shared module. But there's another module in here you might see that's called the core module. I'm not going to dig too deep into this, but a mistake some developers will make are assets like your services and your route guards you might feel inclined to import into your shared module, because you're in the mindset that we're going to be using those everywhere. We don't need to load them in all at once. I only need to load them when I need them. Don't do that. If you import them into your shared module, every time you do a routing to one of those modules that imports the shared module, it's going to instantiate a new version of that service. And services and guards are supposed to kind of exist as singleton objects where there's only one instance across the entire application. We put all of those types of things into our core module, and we'll just import that into our app module. Next topic I want to discuss is canceling our subscriptions. Now, if you guys are familiar with RxJS, which if you've done some tutorials, you probably know a little bit about RxJS. You've seen it, you've used it, you know about subscribing, maybe you've done some unsubscribes, maybe you've done other stuff besides that. There's two concepts we're going to cover in order to improve our use of RxJS. The first one is the async pipe, which if you haven't used it, I promise you it's going to be one of the coolest things that you can use after we're done with this today. The other thing is a function that I personally love called first, but I'll show you a few other functions, and you'll see why these are really important and why these are really cool to make better applications. So, starting with our async pipe. This is a very, very simple subscription. I go into my game service, which is _GS. I get the games object and I subscribe to it. And then I have a variable in my games component where I just assign this.games to games. So anytime my games from my game service emits a new value, I subscribe to the change and I just update the value. And I have my get return games, which just passes that value up to my template. Okay, that's cool. But just by a quick show of hands, does anyone see an issue with what I have right now? I have one, I have two. Okay. The issue that I have here is when I leave this component, the subscription is going to remain active. Now you would think that it would automatically dispose of itself. It won't. The memory allocation will persist, which means if you just navigate back and forth, you're going to be instantiating multiple subscriptions to the same observable, and at some point you will most likely have to deal with a memory leak. So what you should be doing in order to avoid this is to have a unsubscribe. Now you see over here in my on_init, I created a variable called, or I have a variable called this.gameSubscription, and I just set my game subscription to my subscription to the games. And on the onDestroy lifehook, I then unsubscribe from my subscription. Again, fairly simple, but when you have a lot of hands working on a code base, how often do you think someone is going to forget to apply the unsubscribe? How many times do you think someone's going to forget to even set the subscription variable to unsubscribe later? Wouldn't it be really awesome if there was an easier way to do this where I can cut, what is this, maybe 2 lifecycle hooks, instantiation of 2 variables, and applying a subscribe and unsubscribe function? You probably can't do an easier way, but Angular can. And this is it. Before you saw that I was returning this underscore games with my get games, and now I'm just returning the observable. How can I do that? There's something called the async pipe. What the async pipe will do, it'll have the template automatically subscribe to the observable and promises. So if you have a promise that you're attaching to and you want to display the event of the promise resolving, you can subscribe to a promise too in the template. And if you don't see it, there it is. I just do the pipes async, and now Angular will do everything for us. It'll handle the subscribe, it'll handle the unsubscribe. And you saw, I cut down 2 lifecycle hooks, I cut down creating variables, I don't have to remember to unsubscribe or subscribe. Just do the async pipe and the Angular application will do this for us. But there are also times where you probably do need the values. I described a great situation, a great pipe that will allow you as developers to avoid having to handle with subscriptions and unsubscriptions in your views. But sometimes you need those values inside of your components or services. A really good example is if you're using something like the Angular Fire 2 library, the Firebase user object is returned as an observable that you can subscribe to. So let's say I need to get the user's image or I need to get the user's name from the observable. You could just subscribe and unsubscribe to it, but there's probably a neater way to do that. And that's really simple. There's a few functions that you can apply. The first one I want to go over, and it's the one I use most often, is called first. And you can see, I grab my user observable, I chain with the first function, and then right after that first, I chain my subscribe. All the first is going to do, it's going to grab the first value emitted from my observable, and it'll kill the subscription automatically. I don't have to handle with the lifecycle hooks. I don't have to do anything like that. I don't have to remember to unsubscribe. I just use the first, and I will grab that first value. But like I mentioned, there's a few other operators that will alleviate and make it easier for us to grab values when we need them without having to handle with subscribes and unsubscribes. Well, I have the subscribe. I don't have to remember to unsubscribe it. Another one is the take n. And as you see in the console log, all it's going to do, it's going to emit n values before stopping the observable. So let's say you have an observable that's on a timer to emit a new value. If I do emit n, and let's say I set n to 5, it's just going to grab the first 5 values, and then it will automatically kill that subscription. Another one is take while, where it's going to test the value emitted to a statement or a value that you say it should be equal to. If the values don't match up, it will return false, and so our subscription is going to end right there. And the last one is the first with the predicate, which similar to the previous one, it's going to check each value of the emission to the value of my predicate that I pass into my first. If it matches, it'll kill the subscription right there. So it's looking for the first value that matches our expected value. But with all 4 of these functions, I have killed the need to handle unsubscriptions. I'm avoiding memory leaks because I'm not forgetting to unsubscribe them. And if I don't need to keep these subscriptions active, why am I going to? Now, the last thing I want to be able to go over is caching everything. And this can be really beneficial if you're dealing with larger scaled applications or if you have a lot of users who are going to use your application. Not only does this help them make it feel like it's faster because we're going to cache our assets, our templates, our code all into the user's device when they visit it. Consider that with all these assets and resources that cache onto the user's device, that means they don't have to make requests to the network specifically to your servers that are going to serve these assets. That might lighten the load on your servers as well. And this is fairly simple. All we need to do is npm install save the Angular service worker. This is part of the Angular mobile toolkit, and it's really easy to implement. Once you install it, you just enable it. And this is going to update your Angular CLI JSON to say use the service worker, and it will automatically generate a service worker for you based on your code. Now, there's a few other tweaks and considerations to take into account if you want to use the service worker, but if that's something you're interested in, I advise you to visit my guide on building a progressive web app. It's HTTP, no HTTPS, it's a redirect. Please keep that in mind. But it'll go through implementing a service worker as well as building a progressive web app using the Angular CLI and Angular as a tool. So, sorry if this was a long talk to you all. I gift a potato. If you need any resources, if you want to learn more, I want to pass these resources along. The first one is the Angular style guide, which is where some of the lazy loading concepts, the shared module, the core module exist. The next one is an article by Ben Lesh. And if you don't know who he is, you should fix that. He's the lead architect for RxJS. And so he has a really good article about handling observables. And the last one, again, I'm really biased, It's my talk or my guide to building a progressive web app with Angular. So I'm available on the web at all these places: GitHub, LinkedIn, Medium, Twitter. My handle is at Michael Solati, and I don't know if I have time to take questions.
We can do a couple quick questions.
All right, so if you guys have any questions, please feel free to ask.
Have a microphone. Anybody has questions? Okay.
Hi. You said you were going to probably talk a little bit about the Redux with the with Angular CLI. Is there a possibility that maybe there will be some way to, I guess, structure your Angular CLI application with Redux without having to worry about too much of the boilerplate templating?
So just to repeat the question, you were asking about using Redux with the Angular CLI. And I will say that the CLI isn't really designed to handle that for you. I personally feel as if the implementations of Redux and state management have only recently now begun to take a foothold in Angular development. Mind you, that's just personal opinion, so I could be wrong. There are a few really good articles in how to implement it, but I don't think there's any easy way to automatically just turn that on and for it to work. So unfortunately, I think my answer is no, but I would love to be proven wrong if anyone knows a resource.
One more quick question. Yep.
Can you provide an example of when you would use a predicate?
Okay. So, oh man, that's a good. So I think a few cases that we can use a predicate, and a good example maybe is, let's say that in a navigation bar, we are subscribing to a user object, and we want to only keep the subscription active while the user is signed in. That navigation bar might exist across routes, across modules. So it might exist in the shared module, which means it won't fall under the typical lifecycle hooks of our other components and routes. So we could do something to check if the user object if the value of the user object is null. If the value of the user object is null, then we can kill our subscription. We don't have to do the unsubscribe on the life hook. That might be pushing an edge case, but that is a case I can think of where the predicate checking the values might be useful. Another thing is if you're just doing an emission like, hey, this is a really ugly example. But if a user is looking at something and they click poll every 5 seconds, you could keep the based on the value true. You can trigger the refetching, and then when they uncheck it, it'll kill the subscription. So kill the subscription. Again, I am looking for cases for that. I typically just work with first. That's why I showed it on the slide. Thank you.